Hey there, it's Modern Retro Tech, and today we are doing another stream about Wiktionary, Parser, and new interface for Wiktionary for learning languages in LiveView, Elixir, and with some crazy parsing logic. Last time we didn't finish Parser, and today my hope is to finish it finally and to start showing some stuff there. Also, this stream will be the last stream in this series for now. I will get back to it in January, but December will be Advent of Code time. And this time I will be doing Advent of Code in Rust. So if you will be interested in watching that, please follow my stream. And if you want to see more Elixir, there are Elixir videos that I recorded before, and there are also another series of streams about prototyping an audio player with LiveView. I will link them as well to the stream. So that being said, let's go into the Wiktionary stream. Last time we did this parser, we experimented quite a bit with trying to write different implementations of it. And depending on what we want to do, there were several ideas I tried, but in the end, we just went with simple functions that allow you to extract parts of the parse tree and then essentially show them. One idea that I had since was that we can also try to use some parser combinator library, because the code that we write right now really resembles a typical parser combinator. So we had, for example, a section, let me make the font a bit larger. So we had, for example, a section for each language, and we extract this like language section, and that we need to switch to a new state of our accumulator when we go through all the elements that are available on the Wikipedia page, Wiktionary page. So that sounds to me very much like a typical parser logic, and I think we can try to use maybe some existing library to do that. My hope originally was to try to just use typical CSS selectors to extract information that we need, but sadly Wiktionary HTML is not super comfortable for scraping it, so we need to do stuff like that. I think let's start with quick research and see if we have any parser libraries that we can use for that. If not, we will just continue with writing manual extractors, which is also fine. But first, let's see. So there is awesome Elixir. And here there are, I guess, Parser. So there are quite a bit of things with the name Parser. Date and time, ECMAScript. Yeah, Flocky is the thing that we already use. I also can make it a bit bigger, I guess. I think one library, Parsecs, maybe? Yes. Ah, no, that's a different one. Okay. Okay, let's just try Parser, combinators, Elixir. Yeah, so there are two libraries. There is Combine, a parser combinator library for Elixir projects. Then, yeah, so they say that it's significantly faster than Xparsecs. Now, one good thing, right? We don't need to, like, parsing HTML is complex, but that we already done with Flocky. And I'm thinking if we can integrate a parser library with the trees that we get from Flocky, which is like those tuples with attributes, tag, and like internal attributes, because maybe we can then build a really, really simple parser for that. In principle, It doesn't matter what you parse. You can use parser libraries for parsing binary data if you want. You can use it for parsing text. You can write HTML parser in that. But for us, it seems that a lot of hard work was already done by the authors of Floki, and we should just be able to reuse it. So that sounds good. Let's see nibble per sec. I think this one looks almost identical. This is like year, months, and day, and hour, and minute, and second. And I think that is exactly the same. So I wonder what the difference is between them. I think, yeah, nibble per sec is, oh wow, they added a lot of different things there. This is pretty cool. Nibble options. Oh my god, I had actually an idea for library in Elixir for options. Okay, that's a bit different. Okay, I can still do this. One-time password, publisher. Wow, that sounds really, really cool. I should try them. But okay, let's try to start with combine, I guess. Because I don't want to do any super complex code generation there. I just want to see if we can use this. So I want to validate the idea quickly. We will need to add combine here. And we will need to figure out the version. Oh, it hasn't been updated in 3 years. Oops. I wonder then. I guess then we should use nibble per sec. Okay. Sometimes those libraries, they are not updated for a long time, and this is fine. But I feel that 3 years is a bit too long. So version is 1.1. Nibble per sec. Let's see. We will need to. Oh yeah. The thing is, normally compilation won't work as far as I remember because you need to do mixed depth get stuff. But since Visual Studio Code also fetches dependencies, it worked. So of course, nothing changes so far. The only thing, yeah, we got the languages and parts of speech, the stuff that we extracted last time. And by the way, interesting thing, I didn't actually stop this. So this was running throughout the week. So like since last week when I did the stream, and even a bit longer because I think I did it on Thursday and today is Friday. And as you can see, everything works perfectly. So stability of those systems is always very impressive. I think I have some Elixir systems that I really was running for more than a year without any like reloads, without anything. I really love it about this language, that even in development, it is so stable. Now, in our parser, how should we proceed with that? So let's see. We have online documentation. Oh, I actually wonder if they support parsing arbitrary stuff, because then well, it's old, but it's still used quite a lot. Choice either fatal, ignore if not, followed by mini, map, one of option, pipe, sequence skip, 0. Dev parser. Because normally those libraries, they don't support parsing tuples, so we need to see if we can actually easily... Actually, that stuff looks very, very similar, I feel. Times UTF-8 reduce. So they have eventually duplicate diff per sec. Choice ASCII char. UTF string. Set of options. It's binary to be parsed, so it expects all this binary. And in case of combine, does it always expects micro for building against some rules? Add one term to the result, update the position, remove the part bar. Oh my god, I'm now thinking about all the nestings that we also will need to handle. That may not be the best approach then, I guess. I'm thinking if we should maybe try something a bit different then. One approach that I see then continue without stuff. The thing is, Nimble Parsec only defines this binary thing, so you can only define binary parsers, apparently. I also really wonder how to do the... If you have a tuple, what will be the consumption point for that tuple? Okay, bad idea. Let's try to do it ourselves then, so we won't need it. Well, that was interesting thing to consider. If we continue with our current approach, what then can we do? We can start to parse the definition list. So for example, yeah, like was a very good word. You can see that we got a bunch of things here, so it's a very complex page. Thing that I care about is this. But this is not the best language German thing. So maybe we can find something. Okay, this is really lazy, but this word has a lot of meaning. Oh wow, this is also a very, very big page. Maybe then... Okay, there's only one definition. Oh yeah, that is way more useful article than... So here we have two things for conjunction. We have etymology. We have different languages. I think this is a very good example. So if we take it right now, so what we get, let's try to also see what we get from Parser itself. So we got that. This is our crazy HTML stuff. So children is one thing that we care about, and here we can see that we got a bunch of things. If we look at the inspector here, I really wonder if there is some way to increase this font. Sorry, I have not found the way yet. Maybe in settings. Tab size, DOM, style editor, a bunch of things. It's so weird that it doesn't synchronize the font size here with the font that I'm using in the browser. but okay. So I will just try to read it up because I think it's not really easy to see. Once we got the part of speech, the next thing that happens after that is a paragraph, and then we have OL thing. So OL thing is something that is inside. Okay, it's just following the definition for part of speech. I also wonder, so I will say this is raw article and it is equal to parser test Wiktionary article. So then I can look at my output from parser, parse article, raw article. So we got this, and then we still get those blocks, which is a bit weird. Language section start. How do we show this? We do language, and then we have languages map. Now a bit cold. Well, it will. We take previous section name, we get stage results, and we get results, and then depending on section kind. Oh, that I guess is a mistake, right? This is always funny experience when you look at your codes that you wrote a week ago and you're like, what? I feel here, this is because we are trying to do this like complex tree manipulation. And we need to somehow maintain the state here. So one thing, yeah, put subsections under corresponding language sections. We need to maintain a deeper list here, right? That can become even more complex. I guess we will need to do things here depending on the section kind. Oops. And then if it is language, then of course we don't care about the original nodes. What we want to put is some information. There probably will be a map. So right now our logic here, we have language name, we have staged, and we have result. Like one thing that I want to try to do here is to work with map instead of that. So we can try to do full children, and we start with children, And here we have a map. Right? Then if we have different section starts, we can modify our map accordingly. So we can take, yeah, we can actually do the same kind of thing here, right? But, so language section start, language name. And then we need to, let's call it update accumulator. Or like even for now, let's not even extract it. Language name element. Why does it return element? It shouldn't really return element, right? We should just return the language section start and possible language name thing. We already know element in our accumulator anyways, so that we don't need. And then right? So we have current language and language section start. What we do with accumulator, current, we take the accumulator and we say for now, I guess. And previous language. Oh, I guess we can do it even simpler because for each language we will have independent maps. So when we encounter new language, everything we collected before, we can put into the map for that, for the previous current language. So we can say we delete current language from the, from the accumulator. We create a new map. Oh, I wonder if it returns it. Line A. So previous language is right. And then I actually don't remember if dot notation works with plain maps. Let's check. Oops. Yep, it does. Okay. We have current language and then we have a new accumulator, which will be how to so for each language, what will be the shape of our accumulator? For each language, we will have like German, and we have like internal map, right? Then we have staged, which will be map that is current language. Results. Okay, I see. So that will be then the structure, I guess. The current language will be, for example, German or French, I don't know. Okay, and then it should be easy, right? So, this is previous language. Results, it's pretty much accumulator, results. So that's our new schema then for that thing. We take results, we add, oh God, I'm so dumb. I can just do map put here, and then key is this, and value then is staged. And then new accumulator will be right. So that it doesn't like something. What do you don't like? Unexpected. Yeah, sure. So that's what happens when we update language. Now, if we update a part of speech element. So again, we don't need to return an element. So that's kind of the thing. Well, this code can be simplified. Next thing is to, what don't you like? Sure. Okay. So we get a part of speech, and then what we do, we say, we don't do anything, we just take accumulator, and we say staged is part of speech and our part of speech. And here for language name, if we don't extract anything, we just say accumulator. So now the interesting thing, of course, in the end we reach some state where we say what do we have? We have current language, we have results, and we have staged. So and what we just do, we do map put results, No, just results now. And then we take current language as a key, and we take stage stuff as well. And this is our result. So this is our logic now. I think this is way simpler. And then what we get instead of this stuff, we get actually accumulator is a map that always has current language. We can even define a struct here, but I think it's not really needed. Results and staged. And for current language, the type is, it's either string or it is nil. For results, it's a map. For staged, it's also a map. This we don't need, so we can even code result. No, let's code accumulator. And or parsed. So this stuff we don't need anymore. Look how simpler our code became with this. I think it's really nice. Then parts of speech, we have this, we have this. For fault children, we also need to define parsed. And in essence, now when we received, we don't need to do this, right? And in our LiveView, we have language, and then we have attributes, like info. And now when we live reload, let's try to search for some word. So we got all our languages, and then we can just pretty much just display our attributes. I really wonder why I didn't think about this approach to parsing at the first, at the second or first stream. But I guess sometimes you really dump and you don't really get what you're trying to do. So now when we should see, yep. It's a bit weird that we get this empty thing here. Old English. So it feels like, yeah, because I guess we get the empty map for the language that is not there, right? So do we so we put results, we put current language, and we put staged. Let's do and then still we get this. Interesting. We can easily also say this, right? And then we can do oops. So we get this. We get current language. Hey Madhu, yeah, it is really live. I am programming right now. Sorry, yeah, I'm super slow noticing chat messages sometimes because it's on another screen and I need to reposition everything to make it a bit easier to notice. But yeah, eventually I will notice your chat messages. So if you want to say something, please write in the chat if you want to ask me something. And also don't forget to like, subscribe, and do all the typical rituals that YouTube requires from you. Yeah, I'm trying to understand how did we arrive here that we have this nil stuff in result now. I guess maybe I am... Oh, because I'm actually doing it here. So I take the accumulator results and stage. So when we detect the first language, we still have this stuff that is empty. So we will need to add a condition here. If staged actually, yeah. So if current language is nil, or I wonder if we can do map empty on that. What is the official blessed way to get the amount of keys in the map? Will it be like you need to fetch some, or is this some magical? I guess, yeah, we need to do keys and then we need to do lengths of that, right? So let's try it out. And then I guess so map keys, and then we do length, and this stuff, let's call it staged elements count equals to 0. Or actually even, yes, I'm dumb. I should do enum empty. It's more expressive to write it like that. Staged empty. I think we can write it even like that, and that this makes it even more expressive when you put it here. Otherwise, we put stuff. Otherwise, we just say arc results, right? So that should fix the error, I think. Let's try. So we can recompile and we can try it again. You see the empty dictionary disappeared. So that means that this stuff works now. And this actually looks really, really cool. So we get like Welsh. Do we process it? Ah, yeah, this is just before we do stuff. So if we put our IO inspect here, right? One cool thing, you can also always label stuff with IO inspect. So you can say parser result, for example. I think. Oh yeah, this stuff you don't need anymore. So we can compile again. And then when we do something, you see you get this nice label. I really like this feature. It makes, if you do like, This is beautiful. The only thing that we are doing right now wrongly is that our part of speech has multiple, how to say it? Like we get multiple parts of speech, but we put them under the same key, which means we are getting kind of screwed because we lose all of the previous states. So we get like verbs and nouns here and stuff like that, but not all the conjugation. How can we fix it? In principle, if we get a part of speech, we should also create a new map, I guess, because for each language, for each part of speech, we will have its own definitions, right? So it's part of speech, then we need to do, shall we? Parts of speech. Because then our parser state will be also current language and current part of speech, right? Kinda. We will need to track more state. This will become ugly very quickly, I feel. But what can you do? You know what? Before we go all the road with doing this stuff, one thing that we can do to make our life simpler is extract a module from that. Then we will be able to keep track of the state even if it becomes more complex. First thing, though, I will just commit it because I actually want to check out my mix log from master because I tried to add this library and now there is some stuff that is not needed anymore. So maps instead of keyword lists for parser state, right? So next thing, let's do the parser state stuff. For now, I will just be putting it in the same file because I think it's simpler. Or actually, let's just go to a different layout. So we can then do this. So I want to create folder, and here I create a new submodule, parser state, or actually just state, ex. Never repeat parent module name in submodule name or module name in its functions name. It's dump. You typically better off just writing stuff like this, parser state, right? It already is mentioned here. So here, for now, I would say this is strictly private thing for our parser, so module doc is false. This is a way in Elixir to say that something is private without completely prohibiting people to experiment with that. For example, in REPL, I very rarely use diff-p and def module p because those will prevent you from actually doing anything with them in REPL, which is one of the main strengths of Elixir language. So this is my preferred approach to that. If you want to change it or depend on some details from that, you're welcome. But when it breaks, it's your fault. So now with that thing, we can split it, right? Yep. I actually haven't tried ZenMod. Oh, that looks nice. This is like very minimal amount of garbage right now. So what do we do? First, we need to model this stuff. So one thing that I really don't like about maps is that they don't have access defined for them. So you cannot just fetch stuff easily, but I think we actually never fetch stuff via like key here, right? So yeah, we can go for this def struct and we can say, what do we have? Current language. We will need to have results staged. So this is our current state. Then we define functions, right? So new will return exactly this for now. Then we define a function for add language or set new current. I wonder, new current language, set new current language, put is better word here, I feel. And you can use, then you get state, which is the current module. You get the language name. And that is really it, right? So we take this and we pretty much take this body, put it here. So then you can say staged. We can use pattern match now more explicitly. If something is nil, so state current language, this will be a bit longer. Staged empty. We say state results. And then here we can say state results, state current language, and staged. Now you can already see that we even get some inference of specs, right? But so now, what don't you like? Ah, yeah, we need to define a type, of course. Right? We have module. And then we pretty much take this stuff here. Now, important thing is that we should be able to, let's define the part of speech thing and then we can test it, right? So put part of speech. I need to scroll a bit up, otherwise you won't be able to see anything. And here, for now, that's what we do. So right. So that's another thing. Yeah, of course, it's not current language. It says put part of speech. And for new, we also need to define a spec where here we need to do this. So now I think we have everything. We can then say, can remove this. We can do state, can alias it, right? R. Oh yeah. So this is our state stuff here. And here, of course, we need to say state new. Let's be consistent in our naming. State. Here, then this we don't need anymore. We say state, put current language, language name. Here we don't need this anymore either. We say state, put part of speech, part of speech. Here we call it state. Then, of course, we also need another method, finalize, let's call it. Which will do this. So actually, so this is what we need. We define txt and it is returning results. So it returns map. And here then we can just say finalize. Isn't that nice? I think. Oh, of course. We forgot to parse state here and here. Bam. You can also see the dialyzer actually works quite nicely. Now, important thing for us is to check if everything works as expected. So, yeah, we get stuff as we expect. However, we still need to solve our problem with parts of speech overriding each other. So, let's try to do some internal renaming first. In case of results, this name we can now rename. Like, as you can notice, now all logic about this struct is contained in this state module. So we completely extracted it from here, and here we only have like those high-level helpers, like new, put current language, put part of speech, and finalize. And in case of us, like what we return, actually this is not even state, right? It's a map. This map we also will need to specify, of course, because this map will be like mapping between language and then part of speech. And for each part of speech, you will have a number of attributes that we parse. But in general, we still maintain the contracts that we see externally. So here we then have current language. We have then current part of speech as well. We will need to add part of speech, which will be right. Oh yeah, of course, I also need to add it here. Then we have results, which is a map right now with like first language. Let's try to figure out what will be. It will be like language 1 and then part of speech 1. This will be the outline, then language 2. Right, so this stuff will look something like that. I think even we can do it like so, and then you have this, and then you got this. So that's our basic structure. That we will need to maintain in results. Do we have any other subsections? Well, we will have like definitions, which will be a list, I guess. There will be like etymology section. Let's try to figure out what kind of data structure we will need to expect here. So we will have like etymology section per language, I guess. Let's try to look at another thing, for example, like who's there? It can be like etymology 1, etymology 2, etymology 3. Or like so. Here, typically, like in some articles, it will be more complex, but typically you would have like etymology and pronunciation, and then you will have like a number of different parts of speech. I wonder if we now do so. So, wow, this is a lot of languages. There is German is pronoun, it says. So it fetches it correctly. Okay, this is good to know. Like the main thing will be done for each part of speech having those definitions. Which means definitions. So as you can see, our data structure is funny. You'll have a list of those definitions. For now, I don't even want to define what they are. For now, we just put like strings there. And there are like other keys. But that is kind of the basic thing we are working with. And staged, of course, is like this part. So stage current elements for current like attributes for current language part of speech tuple. Yep. We cannot so track it as a tuple because we get those at different points in time. So it may be pretty tough to try to keep it as one tuple there. Yeah. Alex Dev, I've never used Elixir as a programming language. What would you recommend it for? So like all kinds of web development, it's amazing. It's like Ruby, but better, smaller, functional, without all the object-oriented complexity with immutable data structures. with built-in distribution and scalability, and with stuff like LiveView, which is like dynamic renderer. So for example, like one thing, of course, you can always see when you change something and say, I don't know, hey there, and then I don't know, I search something, you can see it here, but that also will work dynamically. So like it's kind of like having a WebSocket web app which is completely server-side rendered without any JavaScript, which is pretty insane. And it also has a bunch of other cool things now. For example, it has integrated dashboard. It has really cool database connection library called Ecto, which I recommend you check out. It's kind of like ORM, but it is more functional. It doesn't try to hide relational model. It kind of allows you to write like high-level SQL pretty much and easily map it to your simple structs and lists and like strings and stuff like that. So it's way less overhead, and it's pretty cool. Another thing, of course, is distribution and fault tolerance and soft real time. But for me, the main thing is metaprogramming, in that it's just such a pleasant language to write. If you enjoy Ruby, you probably will enjoy Elixir. If you enjoy Python, you probably will enjoy Elixir. Yeah, it is indeed amazing language. I also can just recommend going to the official website, Elixir Lang, and they have amazing guides, and they try to sell language a bit better nowadays. It's still pretty small community. You will need to do like a lot of research sometimes. You won't find libraries for everything, but at the same time, building libraries yourself is also pretty fun. And for like more common stuff like web development, usually you are already well covered. So it is quite a safe bet. I've been using it in production for the last almost 4 years now, and so far I'm super happy about it. But yeah, let's try to parse this stuff. I guess we need to, we did this, we now need to somehow implement these attributes for current language and part of speech part. So we have already current part of speech. Now we need to we need to change, I guess, our put part of speech thing. Here then, when we get new part of speech, we will need to, yeah, my pleasure. We will need to go into this structure, into stage a bit deeper. So we will need to have also some helpers for that, otherwise we will go insane. So I guess let's try to put, oops, I'm going too far away in the module. Or shall we even select like stage stuff as well? Because I guess then it will make also sense. But stage is just a plain map. It's not even a struct. Okay, for now I will just write some functions. I guess that's always a good thing. Put new language in staged. I guess I don't know if today we will finish with the parser, but I guess at least we will make it a bit more easy to follow next time. I will be breaking with those streams for Wiktionary throughout December because I will be doing Advent of Code in Rust, but in January I will be back, so this project won't die that easily at least. Let's try to get as far as we can today. I will be streaming for about an hour more, and then we'll take a break. We'll be back on Sunday with another Rust stream, so should be pretty fun. Okay, what do we do with staged? We will need to put a new part of speech there, put a new language there, and put new element in the current thing there, right? Actually, no. We won't need this complexity because state we just track the attributes, and then we only need to care about like languages and parts of speeches when we put stuff here. So like when we have put current language, we copy everything that exists in, yeah, I see. So we will need to kind of navigate to the results for the current language, I guess. And instead of updating whole results, we will need to possibly do like partial passing. So right now we just say results is this thing. We clean staged. If it's staged empty, stage result. Otherwise, we need to put it in results. There is a cool thing called put in. So we can then, in principle, say in state results, we put current language. I think you can pass, yeah. You take current language and then you can current part of speech and you put current stage there. This will be one thing. And this is your results. Then if we have a put part of speech, then we will need to go with, we will need to do also put in. We will take, yeah, right now it just puts it into staged. Instead, we will need to say, we will need to do the same thing essentially here. We say if nil current part of speech. We duplicate this for now for simplicity. Staged empty. If there is nothing, then there is nothing, right? State result. So we keep that, and important thing, we take the state, we change results, we change staged, and we change current part of speech. So that becomes part of speech, right? Otherwise, what we need to do, current language. I guess we will need to do the same thing, right? We just take the current language, we take current part of speech, and we put stage stuff there. And that kinda should be that. And then we don't need those helpers. And then we should just get now a list of like languages, a map from languages to all the parts of speeches, which will be like empty maps, if that works. I really hope it does. Let's try that out. Nothing actually happens so far. Let's try it again. Oh, okay. So we are connected and we can try. Oh, I forgot to enable this, of course. So now we should start seeing stuff again. Actually, I think I can soon switch back to normal view. Okay, we are getting empty everything. I really wonder. I wonder if we are too aggressive in filtering it out, because maybe we just never put anything because we don't yet extract anything for any of the attributes. So current language, we got some stuff there, so we are definitely tracking stuff, but we don't add anything because of, I guess, this condition, right? So I can, for now, disable it so we can actually see stuff. Ooh, something broke really bad. Noun on a nil value. Whoa. Ah, because I guess, well, our results are actually not nil. Staged empty. Stage results, which will be an empty thing. But here we don't say nil, we say stage. We remove everything. Well, end result will be just empty stuff. Okay, let's see where we're actually doing that. So we're doing that in here. Put in because we don't get the map yet, I guess. We are trying noun. We don't yet have language, or what? I guess so. I guess we will need to do it here as well, so that we get the whole structure here. The thing is, we don't yet extract any attributes, and that, oops, why we don't get anything here. We cannot navigate with that stuff. None on a nil value. We put stuff in state result, which at first does not have, I guess, the whole pass. I wonder. I guess it doesn't work this way. We cannot just use put in only. We will need to do like see if we have the map for that, right? So if I say this and I say, oh, okay. So here then, that will be our helper then. It's putting this stuff in the correct map. So let's call it put result for language and part of speech. I know this is hilariously long name, but this is something that I find better than having hilariously non-telling you anything name. So if we put this stuff there, we need to take result for result and results and staged, and we take language part of speech here. And then normally, by the way, one good thing, you can also use keyword arguments here, but for now I will just go simplest possible way. But normally when you have like those arguments that are not really in any specific order, it's kind of hard to remember in which order to put them. Here it's a private function that we use only from this file, so it doesn't matter. But in some situations it's better to just go keyword arguments, so you need to write actual names. Yeah. Thank you, Alex. Yeah, I guess we need to part of speech. Check first if we got stuff in our result, right? So this then, by the way, is the stuff we are trying to do. So we take results, and here results, we say case result. Actually, I wonder if map put, what does it do? Oh yeah, we can just use put new. So we can say results, and we put new the key, which is language. And if it doesn't yet exist, and then we just put an empty thing here, right? We actually then can, we just put an empty map. This will be our results. So if language has not been existent before in the map, we just put an empty map for the parts of speech already. And then, but if it exists already, we don't change anything because we don't need to. And then I guess now let's see if we get this, if we say German and map, you see that this stuff works. So then we can just do output in, and we can say results, and we can say language, part of speech, so like path to the things that we want to put, and staged. And then we can do doc false, and I always prefer to write specs. So results is just a map, language is a string, part of speech is for now a string, and staged is a, how do you call it? Is also a map, of course. So, and it returns a map, yes. By the way, I will switch to this layout again so that we can soon start to see our stuff on our web page. So now if I recompile, oh, I forgot, I actually need to make sure that this is properly used here. And then, of course, I can put the staged empty stuff here. So I will just copy it here for now. We will see if we will remove it later. I guess we probably will, but who knows? So like this is the basis of it. We will just put to do now because it's no longer an error. And here, state results. Then we pass our state current language, and then we state current part of speech, and then we have staged. And we return it. And here we pretty much do the same thing, right? We take state results, and then we can take current language, and we take current part of speech, which can be, by the way, nil. So staged. For now, let's not care about it. So what happens if this thing is nil? If this thing, if part of speech so if it is nil, then we do results, or else we do this. So that will be correct logic, right? So let's try it again and see. So we got, yeah, that's our old bug with this stuff, but now we get map from part of speech to some map of attributes. So it looks better. Staged. Do results. So if it's nil, it means that it's like first language and we didn't really do anything yet. So I guess maybe it makes sense to do it like that. Is it correct? Do we lose anything? Let's quickly check it. Because I think there was 3 languages. So German and Low German, conjugation, and in Old English it's a noun. I guess we are losing something now in our finalize function, right? State before thin, English, none, and staged. Okay, so finalize, I guess we just need to do the same thing, right? What we do language, part of speech, and staged. So we just do it once more. Results, current language, current part of speech, and staged. Oops, I didn't want to do it here. I want to do it here. And here I don't even need to do anything else. I just can do that. Staged. Actually, then this stuff I don't need. I can just say state. And I can, one cool thing, IO inspect returns the value it gets. So that's why we can just do it like that. So that looks correct, which is really nice to see. So that stuff we don't need. And this stuff we already removed. So that's our beta state, right? So let's commit it again and make sure that we have, how do we call it? Part of speech. Pairs attributes parsing. So we done that. We now have correct mapping, and now the next thing for us is to parse the list of definitions. So when subordinating, so we always get like after part of speech, we get this like another thing, which is like when something. Which is like P things. So this is like just definition, I guess, which has like a bunch of, it has now more like interesting classes. So it has one class here is gender. Then it says it says like different forms of the word. But this is already cool because for German, gender is one of the most important things that you need to know about the word to use it correctly in the language. So that is very useful for us. And let's just start with extracting the attribute. So in our parser, we can start adding stuff. So we have already part of speech, and we can do, how do we call it? Word definitions, section start. I think section start stuff we will probably need to retire, but for now, this is okay. Then what we do? So what is the thing? We say this will be always P, so that stuff you don't need. And does it has like any attributes? This is P followed by ordered list. So I think can we check? Like one problem here, of course, is that we cannot use CSS selectors anymore. So what's in X head word? I guess we can try to use this. So one of the children is strong. And strong attributes. Word, right? Then we say word, and here we have strong attributes. In them we will find class Latinx head word. And then if we find that, say true, otherwise say false. And here then this will be word. And we can call this word question mark. And here then we can say word definitions, and just return word, right? I wonder if this will work, but we can try. So now in our state, we will need to just add attributes, I guess. So yeah. Okay, this looks very ugly. We will need to also refactor that, but for now, word definitions, section start to. We need to look at this part and then try to make it a bit better. Oops. Yep, and this thing is called word definitions. Section start. And essentially we can already try to add this stuff here. We can, of course, it doesn't give us any additional information because we already know the word. We have it typed by the user, but this will be a good sanity check for us to see that we associate stuff correctly. So state put attribute. So this is what we need, and if it's nil, well, we return state. So key and value, that's as simple as it gets. Actually, we can even call it put. No, let's stay true to our domain and say what will be our spec. We get something and we get something and we return t. And this is pretty simple because we just take our state, we make sure that it's still inside the struct, and in staged we say state staged. Oh no, we cannot do that because the key may not exist, so we do map put stat stage key value. Actually that is, well, that's actually okay, this is not too bad. And then we can see, so okay, we only extracted it for English, Old English. I wonder for German then, for example, Old German, class Latin head word, and in German it is Latin head word. Okay, so we can say classes, right? Word definition section start. Start classes. And here we will have a bunch of things. We'll have this head word. And this attribute we have done it, and we can try it again. Let's try again this one. Still nothing happens. Interesting. Word when. We are here in German, right? It's B. Class is Latin head word. Latin. Oh God. How does it generate it? I really wonder. Okay, we got it. Let's try something more funny. Ooh, you can see that in English we got a bunch of things, which is really nice. French, German. So yeah, actually we got words for all those like European languages, even Spanish, which is nice, and French, which is also nice, and Norwegian. Okay, cool. I think for now this is good. Let's add one additional feature. And if we have enough time, let's try to remove this crazy staircase. So this is like kind of like choice construct, right? We'll just need to use like a list of things here instead of having go in this stuff. That, by the way, was the original inspiration for my idea about using a parser combinator library, because that's kind of choice. Like you need to choose one of those things. The first one that matches, you go with that. But I guess we don't have such a very low interference combinators yet, so need to do it manually. By the way, why don't it like it? What is our lm thing says? Return state, extract, kind, and attribute. Oh yeah. So that thing is new, so we need to add it. You can see that dialyzer is really powerful sometimes. It can even track this stuff. So actually, when I think about it, let's do it a bit nicer and more Elixir style. Why don't you like it? I guess we cannot use this stuff for types. Okay, this is sad, but fine. Actually, I think we can eval stuff here in this context using quote fragments in, but okay, let's not go so crazy for just specifying a bunch of attributes here. Now we got the word, and now let's try to get the definitions themselves. So definitions live in this ordered list. Definitions, got, which takes the element, then can copy this thing, and this thing. Where we can say that we take OL and then we can just take each li before DL, if there is a DL. So we take OL stuff, and then we can... Oh, actually, that should be parsable with Floki again. And this thing is, seem to be, at least, labeled. So you can say this is children. And then we can say, what do we want from them? We want, for now, let's just try to get the text of the definition itself. So you say to do examples extraction, right? But here we will try to extract everything. So we have this children when is list children. In case it's an empty thing, let's just process it so we don't need to care about it. We just also return nil. And then we need to, let's see how Floki allows us to do that. Because here in principle, from this element, we can do extraction HTML Elixir. So we can say Floki find for now, we just will try, I guess, find and update. I wonder, because I want for now to just kill it. Match the selector. Yeah, we can just say delete. So we can say children. Or even children. No, it wants a tree, so maybe it will break. So let's just give it element, and then we can say, what is our CSS selector? It's just DL. Does DL has any kind of type? 9, just DL. Okay. And we just want to delete it. For now, we just remove them for simplicity. Right? This will be our children. sure. And then we will just say flocky. I think it has like text, yes. So we can just say children and say definitions. Oh, I'm dumb, right? I need to take all lists now. So what will it actually return? So like noun. Yeah, good thing, since we are in Elixir, we can, and it's dynamic type language, it's very easy to test what we get here. So we can just say definitions and put an element there itself. Sounds a bit dumb, but it will allow us to inspect the state and then play with it in interpreter, which is way easier to work with. So we can say case word definitions. We take the element. Yeah, we definitely need to get rid of the staircase stuff because it's so ugly. And here we say if we got definitions, we just put it definitions, got it. What don't you like? Definitions, okay. So now we will also get the stuff printed, right? We can do, woo! No case clause matching. Where is it not matching? Definitions, OL. Oh. Yeah. So, but how? Definitions, and then we get nil, and we get state. Isn't that what we want? Let's try again. Start with a simple example. Woo! We got the stuff. So that's how our tree looks like. We can then look at the German tree and just copy it. So we can say get conjugation. Got word when. And I think, is it well formed? Okay. Definitions is that. Oops. Definitions. Is it correct? Oh, okay. So we got this like monster tree. Well, not really monster tree, but you can see that we have a list of things here. And now we can just try flocky functions on it. So we can try flocky find. We can say definitions, and we can say find me all li. And it returns list. Let's see how many elements it has. 2. Let's try to say we can match it. Definition 1, definition 2. Then definition 1 is this. Definition 2 is that. And then we can try to also do flocky find and update. Definition 2. We find DL, we delete. What will be the result? Oh, it expects a function, so we can check. So it expects to find a string and HTML attribute. And this function then returns string HTML attribute or delete. So okay. Well, then we already know that our stuff will fail, right? We just need to update it. We say that this is a function. It takes anything and it always returns delete. And we just removed it. So that sounds good. And of course, now when we have this div to clean, let's take this and say flocky text div to clean if on the condition that. Well, we are missing space here, but that is already good, right? Oops. How did I delete it with this stuff? I think one of the main things about REPLs is that they reduce the iteration delay so much. So you could see how fast it was for me to try those functions and learn how to use the library interactively. Imagine first writing tests for that and using DTD instead. This is so much slower. So REPL is a real power. Definitions. So, okay, that we actually don't do yet. We need to do flocky find. We find all Li in our children, or like even in our element. And then case, yeah. So we do case 2, and here we can say if it is definitions, if it's an empty list, you return nil. If it is, actually that case we don't need anymore. If it is when it is not empty list, definitions, we can then say we can map them. So we take definitions, we take definition, and here we then say this. So that is one thing. We remove for now, we just remove examples for simplicity. Then this will be our definition, right? So and here then we say flocky text definition. So also proper spacing around links. So now we finally should start to see some useful information with that. When, if on the condition that when sits on the skin, really? I never actually looked at what it says. Yeah. Okay. Now we know. Like, let's see, Danish, internet like, word like, verb, internet like, English. Thomas, okay, like English stuff is completely broken for this article. In German, also not the best thing, I guess, as equally Hawaiian works. Let's try to phenomenon, face. Actually, okay, let's see if it's a Gesicht. Noun. Like, we need to get this list here. I wonder why we don't. So we get noun thing, right? We get word Gesicht. Yeah, we only get this one. Ooh, but we have like 2 different nouns. So that is also interesting. So we need to process that then. How can we actually handle this state? So see, the thing is, I guess we will never be able to fully parse Wiktionary. We will be only able to parse it partially because there are so many exceptions and those articles are written by humans. But at least we are getting somewhere. I guess at some point we will reach a state where it will be sufficient for it to become usable. It's hard to predict when this magical moment will happen. Please put semantic classes in your HTML that makes life of other people very simple. But for now, let's try to then part of speeches are not unique, right? So when we do put part of speech, we need to add additional condition here. Let's also add some comments here because it's pretty complex stuff to figure out. So processing first initial state contains empty part of speech. So you shouldn't add anything in that case. Then here, sometimes we have several parts, several identical parts of speech for the same language for different word definitions. So those are like really edge cases that we need to work with. So put in, we cannot just use, we need to check. So we check if, we know that there is a language, we need to check if there is get in. So in results for language, we can check if part of speech exists. We can do this. Or we will need to put another, right? We will need to rename it. We will need to call it like if something already exists here, we will just need to call it handle more than 2 different sections for the same speech. So for now, I will go with like very basic approach where I do this. Don't kill me. Simplest thing. Let's try it again. Oh, and we got the stuff. So it's still like we don't get any nice like we got the definitions correctly, but we don't get like proper spacing yet. So that we will need to fix. And of course, we only support like 2 same parts of speech, but still it looks way better already. I think it's pretty cool. Ah, yeah, there are like quotations that we also put there, but that we can also handle. So I guess that's it for parsing for now. We got some workable scheme. It is a bit long, but it is working. There are a number of things we will need to fix when we return to this project. There is also this stupid structure where in essence, we can actually say, like, how would you model this logic? Let's do the last thing to, so I'm sure that code is not super ugly. How would a perfect description of this logic look? I mean, like this, oops, this stuff. For that, we just need to associate, right? We need to say functions that we need to use. So, right? Then we have the expected tag, which we actually don't even need anymore. We can just do this. And then we can do so we can do it like that. We can then go here and say part of speech section start. And here we say state, put part of speech. And here we can then say, oops, word definition section start. And here the only interesting thing is then, of course, attribute, right? But thankfully in Elixir you can also do that comparatively easily, right? We can do put attribute, and here we then do 1. So we get exactly the same interface. And then we can even do word definitions. So you see, we can extract the stuff. We can extract our logic here as a data structure, which is just a simple list of tuples where both keys and values of tuples are functions. First function is the extractor we're using. Second function is a function that always accepts state and what we have extracted from the extractor if extractor returned not nil. And then we use partial application to specify correct attributes. So we can just do it like that. Definitions. And now you can see that we have exactly the same structure. Like this is same logic that we just described as this ugly thing. We only just need to add a little helper that will process it correctly. So we say extractors. For now, we'll just keep it as a local variable for simplicity. This stuff is correct Elixir. We will need to change our extractors. Let's just first thing do this. So make sure that we always return. Actually, we can always return OK. We can always go with this. So we can say extract will always be OK and attribute, and that stuff we can kill. We can then do OK. We can then also add processing of errors comparatively easy here, right? We can say OK. And here we also say OK. And then what we do for element, we say we need to essentially do reduce file now. We take our extractors, we take our, do we do even reduce file? So like on reduce file, it allows you to terminate faster. We don't even need reduce file in principle, but this is like one of the cleanest way in Elixir to do quick termination. If you were using one thing where imperative languages are better, we could have just did break or return the result here, but here we need to be a bit more careful. We take extractors, we take our thing, which will be just nothing really. Our accumulator, we don't need accumulator here. And then we just say, okay, we have a function that takes the current extractor, and that takes the state. So accumulators that we don't need. Use file. Halt. So then if we just apply extractor, so we take extractor and we apply it against, yeah, we get extractor and we get state, state modifier. We take extractor, we apply it to our element, and we do it in case where you say if it returns OK, and then extracted, we take state modifier, we apply it on our current state, and we use extracted. And if it returns nil, we and this will be our halt state. So that's what we return. If it returns nil, we just do cont nil, and that's it. So now, if I did everything correctly, which we will know in a second, we should be able to do this with this code. It already doesn't like it, but we will see. Sometimes it has problems processing this kind of stuff. Something broke. Put current language. State. So put current language, cut state, which is not called state here, I guess. Oh no, it is. State and got extracted. Put current language, part of speech language. Let's see. So we extracted the language, and when we called put current language, it broke because it expected module. Definition 12, blah, blah, blah. parse articles. So let's do it a bit more state equals to this, right? Because then we can also say inspect extracted to see what we applied with and where it breaks. So we will need to do it like that, state and extracted, and we can do recompile. And then we can try. What did we get? Nil in German. State is nil. Oh. How come? How come state can be nil? State new. State nil. Halt state. I really wonder because we extracted stuff correctly, but our state is incorrect here. I wonder why. It doesn't make much sense to me. Yeah, this variable is definitely unused. Ah, because in other situations it returns nil. Okay, so I see. I need to pass state. I need to pass state here. So otherwise, this what we need to do, I guess. And then, yay, it works. So as you can see, yeah, we get really nice output of parser as well. And our code is now way simpler. So that is literally the thing. Yeah, it was breaking because when we got state that is, like we used nil as accumulator, and then if nothing matched, then nil was returned, and then it was used by fault children as the new state, and then we got problem. But in this case, I always initialize the state, and then I pass it around until I return something, or I just return the state unchanged. So as you can see, the power of functional programming here. This is now the flow control. We can now also do one final step. We can see, we can make it a module attribute, say extractors, and then we can take it. And we can, or cannot we? Language section start. Oh yeah, it will be, okay, no, that will be a bit too much because we will need to first then define functions and change our, I guess, order of definitions, which you don't want to do. But let's do add your new extractors here to enable to automatically apply them on Parsing pass. And here then, let's separate stuff. Let's say extractors. Is it parse article 1? Yeah. So those are extractors, and then we have helpers. Isn't it beautiful? So that is, let's see if we get any, okay, we don't get any compilation warnings, so I guess yeah. To avoid excessive nesting. So, thank you so much for watching. This was last stream in this series for now. I will be back with this in January. We will continue, hopefully finishing this parser, and then also doing some more beautiful interface with LiveView. I think it was quite cool how we were able to simplify our logic in the end and refactor it to something way more maintainable. So I hope next time I return it after a month, I won't have as much problem trying to understand my own code. And yeah, starting from December 1st, I will be doing streams about Advent of Code. I will be solving Advent of Code this time in Rust. 2 previous years, I solved it in Elixir, which was very fun. I'm quite interested how it will go with Rust. So if you would like to see that, don't forget to subscribe, and I will see you very, very soon. Thank you.